Assalamualaikum, my name is Luqmanul Hakim bin Muhammad Sharifuddin. My matrix number is 04DAD22F1012. And I'm from class DJA30023. I would like to presentation about automotive technology 2. From the first slide, describe the purpose of engine management system. Engine management system monitors, regulates, and optimizes various aspects of an internal combustion engine. It can control fuel delivery, ignition timing, emission levels, and other critical parameters to ensure efficient performance, better fuel economy, and reduce emissions. Engine knocking problems or symptom and its solution. Engine knocking, also known as detonation, occurs when a fuel mixture in combustion chamber ignites unwanely or prematurely. It produces a knocking or pinging sound, often caused by low octane fuel, excessive carbon buildup, incorrect ignition timing, or engine temperature. The solution includes using higher octane fuel, ensuring proper maintenance to prevent carbon buildup, adjusting ignition timing, and keeping the engine at optimal operating temperature. If the issue persists, professional inspection might be necessary to identify and address the root cause. For sensors and actuators of engine management system, its common problem and its solution. First, mass airflow sensor, MAF. The problem is dirt and debris accumulation on the MAF sensor can lead to inaccurate readings, causing issues like poor fuel economy, raw idling, or engine stalling. The solution is regularly clean the MAF sensor using specific cleaning solution designed for this purpose. In severe case, replacement might be necessary. Second, oxygen sensor or O2 sensor. The problem: over time, the oxygen sensor can become contaminated or fail, resulting in incorrect air fuel mixture readings. This can lead to decreased fuel efficiency and increased emission. The solution: replace the oxygen sensor at recommended intervals or when malfunctioning. Ensure you use the right sensor for your vehicle's make and model. Third, throttle position sensor or TPS. The problem: a malfunctioning TPS can cause erratic idling, poor acceleration, or difficulty starting the engine due to incorrect throttle position signals. Okay, the solution: calibrate or replace the TPS on manufacturer recommendation. Ensure proper installation and adjustment to maintain accurate readings. And lastly, fourth, idle air control valve or IACV. The problem: a faulty IACV to unstable idling, stalling when the vehicle is at a stop, or difficulty maintaining a consistent idle speed. The solution: clean or replace the IACV as necessary. Sometimes, a cleaning with throttle can resolve the issue, but replacement might be required for severe malfunctions. Purpose of forced induction system. A forced induction system increases an internal combustion engine's power output by compressing the air entering the combustion chamber. By doing so, it increases the air density, allowing more oxygen to mix fuel for combustion. The system typically involves a turbocharger or a supercharger to force more air into the engine, resulting in improved power, torque, and overall performance without increasing the engine physical size. Two types of forced induction system. First, turbocharger and supercharger. The difference between supercharger and turbocharger is supercharger is easy to service and maintain, and turbocharger is difficult to service and maintain. Turbocharger, the advantage is fuel economy. Can improve fuel economy by making the engine more efficient. The disadvantage, turbo lag. Some turbochargers suffer from turbo lag, a delay in power delivery before the turbo spools up. Advantage of supercharger, linear power delivery, provides a consistent power boost across the engine RPM range. The disadvantage, more heat generation. Due to its direct connection to the engine, it generates more heat. Common problem for both type of forced induction system and its solution. Heat build-up. Problem, both supercharger and turbocharger generate heat during operation. Excessive heat can lead to reduced engine performance, potential damage to engine component, and increased wear on the forced induction system itself. Okay, the solution. First, intercoolers. Installing intercoolers is a common solution. Intercoolers reduce the temperature of the compressed air before it enters the engine, improving its density and preventing pre-ignition issues. And lastly, the solution. Coolant system. Some system utilize coolant to help dissipate heat from the forced induction system. Water coolant, intercoolers, or dedicated coolant lines can be integrated to manage temperatures. The source of vehicle emission. First, combustion engine. Second, exhaust system. Third, fuel evaporation. Type of harmful gases. First, carbon monoxide or CO. The effect is reduce the blood's ability to carry oxygen, leading to adverse health effects, particularly impacting the cardiovascular system. Second, nitrogen oxide or NOx. The effect is contributes to smoke formation, respiratory issues, and can lead to the formation of acid rain, harming ecosystem and aquatic life. Third, hydrocarbons HC. The effect is contributes to the formation of smoke and respiratory issues. Some hydrocarbons are considered carcinogenic. And lastly, sulfur dioxide or SO2. The effect is can cause respiratory problems, particularly in individuals with pre-existing conditions. Also contributes to acid rain. The work operation of EGR and PSV system. The difference between EGR and PSV is EGR focus on reducing nitrogen oxide emission by recirculating a portion of exhaust gas to lower peak combustion temperature. PSV primarily targets the elimination of harmful gases and vapors from the engine crankcase to reduce emissions of hydrocarbons and particulate matter. The work operation of EGR is when the engine operates under specific conditions, typically at high load and high temperature. The EGR valve open, allowing a controlled amount of gas to flow back into the intake manifold. Okay, the work operation of PFV. Crankcase gases, including unburned hydrocarbons, are captured by the PSV valve and directed back into the intake manifold. The common problem of EGR and PSV system and its solutions. First, EGR. The problem is EGR cooler failure. The symptom is overheating, coolant leaks, and increased emission. The solution: regular inspection, cleaning or replacement of the EGR cooler, using the correct coolant and addressing any cooling system issues promptly can prevent failures. Okay, next, PSV. The problem is PSV valve malfunctions. The symptom is increased oil consumption, poor engine performance, and elevated emission. The solution is regular inspection and replacement of the PSV valve using high quality engine oil, maintaining proper oil levels, and adhering to recommended oil change intervals can prevent valve issues. Automatic and Tiptronic transmission. The difference between automatic and Tiptronic transmission is automatic operates entirely in an automatic mode without driver intervention in gear change. Provide a simpler, more user-friendly driving experience. Okay, the Tiptronic transmission. The difference between automatic is offer drivers the option to switch between automatic and manual gear selection modes. Next, provide a compromise between automatic convenience and manual control for drivers who want more engagement in gear shifting without a full manual transmission. The torque converter component with diagram and its work operation. When we look at the diagram of torque converter, it has impeller cover, assembly pump, stator, turbine, torque converter clutch, and cover. The operation is the turbine has splines in its center that merge with splines on the end of the transmission input shaft. The converter impeller pump is actually part of the torque converter housing. It is the part that is closest to the transmission. When the converter housing impeller rotates at idle speed, fluid is thrown from the impeller toward the turbine, the driven member of the torque converter. The centrifugal force of the rotating torque converter also thrown fluid to the outside of its housing. Last slide. A block diagram of parallel hybrid system in hybrid vehicle. In parallel HEV, the heat engine and the electric motor are connected to the drive shaft through separate clutch. Power requirement of the electric motor in the parallel hybrid are lower than that of an EV or series hybrid because the heat engine complements for the total power requirement of the vehicle. Lastly, the propulsion power may be supplied by the heat engine, by the battery motor set, or by the two systems in combination. That is series AMD parallel hybrid comes in a variety of types. Thank you for your attention in my presentation. Thank you.